Hello dear students, we'll start the next topic from solution chapter, that is depression in freezing point. Now depression means decrease or lowering, we can say. Freezing point, the freezing point temperature is the temperature at which the solid and a liquid of a substance, solid and liquid state of a substance will have the same vapor pressure. So let us take vapor pressure along y-axis and temperature along x-axis. So for this also we'll consider a solution of non-volatile solute in volatile solvent. Let this be AB. So AB represents the increase in vapor pressure with respect to temperature for solid solvent. Then curve CD, say CD, and curve EF. From CD and EF, the vapor pressure of EF is always greater than the vapor pressure of CD at any given temperature. So EF represents the increase in vapor pressure with respect to temperature for pure solvent. Whereas curve CD represents the increase in vapor pressure with respect to temperature for solution. Now curve CD and EF will intersect the curve AB at point C and E respectively, which means at point C the vapor pressure of solid solvent and solution in liquid state will have same vapor pressure. So the temperature with respect to point C is known as freezing point temperature. Freezing point temperature of solution. Similarly, for EF, point E represents the intersection point of curve AB and EF. So at point E, the vapor pressure of the solid solvent and the pure solvent in liquid state is same. So the temperature with respect to point E represents the freezing point temperature of pure solvent. So let it be TF naught. Now you can see here TF naught is greater than TF. That is, the freezing point temperature of pure solvent is greater than the freezing point temperature of solution prepared by dissolving non-volatile solute in volatile solvent. So what we can say from here, when we add non-volatile solute in volatile solvent, the freezing point temperature decreases. And since it decreases, we use the term depression. So therefore, depression in freezing point, that is delta Tf, is equal to Tf naught, that is freezing point temperature of pure solvent, minus Tf, that is freezing point temperature of solution. Now experimentally, it is found that delta Tf, that is depression in freezing point, is directly proportional to m. M is molality. And we know molality is a quantitative term. So therefore, depression in freezing point is a qualitative property. Next, let us see the relation between depression in freezing point and molar mass of solute. Delta Tf is directly proportional to m, that is molality, or delta Tf is equal to Kfm, where Kf is molar freezing point constant. From here, delta Tf is equal to Kf, molality is equal to mass of solute by molar mass of solute multiplied by mass of solvent, and this multiplied by 1000. Or, we know depression in freezing point is equal to Tf naught minus Tf, that is freezing point temperature of pure solvent minus freezing point temperature of solution is equal to Kf Wb by Mb multiplied by Wa, and this is multiplied by 1000. So this will relate the molar mass of solute and depression in freezing point. So let us see a numerical from this topic. So 1 gram of a non-electrolyte solute dissolved in 50 gram of benzene lowered the freezing point of benzene by 0.40 Kelvin. The freezing point depression constant, that is Kf, is 5.12 Kelvin Kg per mole. Find the molar mass of the solute. So let us start by writing the formula. So for depression in freezing point, the formula is delta Tf. Now we'll use here delta Tf equal to Kf Wb Mb Wa, and is multiplied by 1000. Now here, instead of Tf naught minus Tf, we'll use delta Tf because they have given here lowered the freezing point of benzene by 0.40. That means this is depression in freezing point, that is delta Tf. So let us start with the question. 1 gram of a non-electrolyte solute. So 1 gram is the mass of solute. So Wb is equal to 1 gram dissolved in 50 gram of benzene, which is the mass of solvent. So Wa is equal to 50 gram. Lowered the freezing point of benzene by 0.40 Kelvin. That is delta Tf equal to 0.40 Kelvin. The freezing point depression constant is 5.12. That is Kf is equal to 5.12 Kelvin Kg per mole. Find the molar mass of the solute. So Mb is equal to question mark. So delta Tf is 0.40 Kelvin equal to Kf is 5.12 Kelvin Kg per mole. Mass of solute 1 gram. Molar mass of solute you have to find. Mass of solvent is given 50 gram. So 0.40 Kelvin equal to 5.12 multiplied by 20 Kelvin Kg per mole. Gram. So Kelvin cancel. This will be kg, so kg cancel. This kg will be cancelled. So if you simplify, Mb is equal to 5.12 multiplied by 20 divided by 0.40. So if you simplify this value, you will get 256 gram per mole. So the molar mass of the solute is 256 gram per mole. So in the next video, we'll study the last colligative property, that is osmotic pressure. Thank you.